Okay, this is 8th hour pre-calculus, right after an evacuation drill. Hopefully we're all here. We're missing Larissa. Did she get trampled on by everybody as we were stampeding back? Oh, okay, all right. Okay, yearbook or something? And Mallory is on vacation. We hope she's having a good time. Mallory, if you're watching this video, we hope your foot's doing well. And she's up north. We missed the challenge of getting you to laugh in class. That is a good time. So, and Jensen and Trenton is here. Okay. So yesterday we talked about odd and even functions. Even functions were symmetrical about the y-axis, and odd functions were symmetrical about the origin. Today we're going to look at 3 types of symmetry, 2 that we looked at yesterday, but we're going to give them slightly different representations. So graphically, if you are going to have symmetry about the x-axis, you might have a graph that looks like this. This graph has symmetry about the x-axis in your notes. And the way we test for this symmetry replace y with negative y, and the equation is the same. Okay? No. I have the answers, but I don't have a key. So I have the answers written down. Marlene, do you have the sheet? Here we go. Here's all the answers. I don't have them all worked out, but I believe that you just need to find m. That's it. Just as a slope. Ooh, don't do it all. Okay. Now, what if we're looking at symmetry about the y-axis? Well, that's different. This is symmetrical about the y-axis. The absolute value function is. And the way that we check for that is we replace x with negative x. And the equation will be the same. Now, finally, if something is symmetrical about the origin, any line that passes through the origin, such as, say, this line, I did my best to pass through the origin, that is symmetrical about the origin. And in that case, we replace x with negative x and y with negative y. The equation stays the same. We won't discuss the geometrical meaning. I think you guys understand what it means to be symmetrical about something. We talked about that yesterday. So I know this looks like garbage right now, but this is going to be nice reference to you as we try the next problem. Why are we doing this? Really for 2 reasons. Number 1, we want you to have the understanding and the type of critical thinking. Second of all, I would like you guys to be able to have an idea of how to graph things that are symmetrical. So when I graph something, if you put something on the board, like an equation, generally I can look at it and say, oh, that has a certain symmetry. So as I start to graph it, I can use symmetry to graph it more quickly. So for example, an absolute value function, if I know half of it, I can generate the other half through symmetry. So it helps you graph things more quickly. So let's try that example with this one right here. It says make a table of values and sketch a graph of the following equations. Find the x and y intercepts and test for symmetry. So let's start with the x and y intercepts, and then we'll do the symmetry, then we'll make the table, and then we'll do the graph. Kind of do it in reverse order. Do you remember how to find x and y intercepts? If you want to find the x-intercept, plug in 0 for y and solve. If you want to find the y-intercept, plug in 0 for x and solve. So What would you like to start with? Do you want to find x-intercepts or y-intercepts? Let's do y's. So we plug in 0 for x. So we have y is equal to 4 minus the quantity 0 squared. What is 4 minus 0 squared? 4. So the y-intercept is 4. Now let's switch it. Let's find the x-intercepts. Well, I'll plug in 0 for x, or 0 for y, excuse me, and I'll solve for x. So 4 minus x squared. How do you solve that? Okay. Danny would like to add an x squared, so x squared is 4. Square root both sides. X is plus or minus 2. So I've now found the x-intercepts. I found the y-intercepts. Those are important parts to being able to graph. Another important part of being able to graph is to find symmetry where it exists. Do you know what shape this makes? Starts with a, what did you say? Downward parabola. Yeah, it goes down. Its vertex is up at 4. Yeah, so this, and we found the y-intercept. It's at positive 4. And then you have x-intercepts at positive 2 and negative 2. So if I sketch a quick graph of this, you guys should be able to tell me right away. Is that symmetrical about the x-axis? No. Is it symmetrical about the y-axis? Is it symmetrical about the origin? No. So it's symmetrical about the x, or I'm sorry, it's only symmetrical about the y. Let's show that through our symmetry tests. So, in order to test for symmetry about the x-axis, I replace y with negative y. So, my equation is y equals 4 minus x squared. So instead of a positive y, I'm going to write negative y equals 4 minus x squared. I want to know if that is the same as that. So since y is solved for here, I will solve for y here. Divide everything through by negative 1. I get y is equal to positive x squared minus 4. Is that the same as what I started with? No. So it is not symmetrical about the x-axis. Sad day. That's precisely what we thought. We did not think that it would be symmetrical about the x-axis. In order to find the y-axis, what I do is I go y is equal to 4 minus the quantity negative x squared. This is the mistake that my pre-calculus students made last year. Not Marlene. Marlene's not one to make mistakes like this. She's very careful. How many negatives do I have here? 3. 1, 2 because of the squared, and 3. So is the final result going to be positive or negative here? Negative. So as you can see, this becomes y equals 4 minus x squared. Is that the same as above? Yes. So is it symmetrical about the y-axis? Smiley face. Yay. What a good day. What do you want? You have a very good question. I do not understand it. So go ahead, ask it again, and then if I don't get it, then maybe somebody, if everybody could listen to Hannah's question, and then we could kind of see where so, okay. Yes. Okay. So, Danny, are you going to translate, or are you going to, are you going to answer her question? I think so. So, if you have a negative x quantity squared, that's the same thing as negative x times negative x, right? Which is the same thing as negative 1 times x, right? Negative 1 times negative 1 is positive 1. X times x is Did I answer your question? Excellent. We got through that together. Is it symmetrical about the origin? Let's replace y with negative y, and let's replace x with negative x. So now I do both of them. Oh boy. I've got negative y is equal to 4 minus what? Yep, we get to Hannah's question right here. So we got a 4 minus x squared. And now we want to get rid of that negative, so we got y is equal to x squared minus 4. So is that the same as what we had above? No. So sad face with tongue sticking out saying boo-hoo you. It's not symmetrical about the origin. So I've made a graph. I've tested for symmetry. I found the x and y intercepts. Now it's just let's go back and look at some table values. Knowing symmetry helps you to actually make table values. For example, it's symmetrical about the y-axis. So what would be a good x value to plug in? What is the x value on the y-axis? Settle. X equals 0, y equals 4. So then anything on one side will be mirrored on the other side. So let's plug in x is 1. What would y be? 3. So that means if I plug in negative 1, I will also get positive 3. Let's plug in 2. 4 minus 2 squared is 0. So that means if I plug in negative 2, I will also get. So you can see that you can generate table values pretty quickly if you know about symmetry. Any questions? Do you think you could do one on your own? Flip it over. Whoop. There we go. Here's a line. Why don't you at least see if you can do the x-intercepts and the symmetry tests and see if you can figure out where those are. Try it on your own. I'll press pause, and I'll give you about 3 minutes. Okay, we'll see what you got. X should be 2. Y should be negative 3. Did you get those two? Very good. So you could actually sketch a graph at that point because you know it's a line. X is 2, y is negative 3. So you know the graph is going to look like this. Is that symmetrical about the x-axis? The y? The origin? No, it's not symmetrical at all. So for all these tests, you should come up with no symmetry, all sad faces. Is that what you have? Is there one that you're confused about that you'd like to see? Okay. Then you can obviously make the table. If you're going to make the table, this is one that I do want to go over really quick. You might want to generate some values, and you need to be smart about the values you generate. And sometimes it's easier to generate values if you solve for y. So in this situation, negative 2y is equal to negative 3x plus 6. Divide both sides by negative 2. Y is equal to 3 over 2x minus 3. Now, I'm going to assert that there are better values to plug in for x. We should be smart about the values we plug in for x, that there are nice numbers to plug in. Anybody want to guess what kind of numbers we should plug in? 0 is a good idea. Let's plug in 0 and we get negative 3. It's a good try, Tara. Ultimately incorrect, but good try. When we plug something in, every time we plug something in, we end up dividing it by. Starts with a T, rhymes with oo, 2. So if we divide it by 2, then I should plug in what kind of numbers? Even numbers. So let's plug in 2. 2 times 3 divided by 2 is 3. Minus 3 is 0. Let's plug in another even number, 4. 4 times 3. 12 divided by 2 is minus 3 is. Oh, look at this. If I go up by 2, I go up by 3. We know it's linear, right? So I could just increase by 2, increase by 3, increase by 2, increase by 3, and I could continue to make all the values I want. Right? those are the type of skills that we should develop as we're working through, so we're going to practice some of that stuff, okay? All right. Let's put that away. So, do you know how to find midpoints? Do you know how to do distance formula? Do you know how to test for symmetry? Do you know how to find x, y intercepts? Do you know how to make tables and graphs? Yes. So now let's learn something that you don't know yet. And this is exciting because you guys have been held back. You guys have only been told how to graph certain things, and they are all called functions. For example, this is a function. Can you tell me what makes something a function as opposed to not a function? Okay, put a line up and down. Okay, I got mine. Right here? Anywhere. Ooh, drag it across. Does it ever cross more than once? Well, what about this, though? As you look at this graph here, if I look at this one, ooh, 3 times. Oh, it's only the vertical line. Oh, the vertical line test. Yes, because a function says this. For every input, there's only one output. So as you can see, if you plug in this x value, you only get one output. This x value, one output. This x value, one output. But can you have can you have one output correspond to 3 different x values? Yes, that's okay. Now, here's the thing. Because you can only graph functions up till now, you have not been able to graph things that look like this. Circles. Ellipses. Hyperbolas. Sideways zigzaggy things. Isn't that sad? Marlene, you know how to graph these, right? What a wonderful time that was. Do you remember when we had our unit on conic sections? And it was all wonderful and bliss. You're like, oh, this is so wonderful mathematics. Well, let's just stick with this one right now. Okay? We'll do the circle. Circle, circle. All right, so let's do circles. And I'm going to tell you guys that after today, you will know how to graph circles, and you'll say, that was easy peasy. The only problem is that hyperbolas are infinitely more difficult. So we start here. Equation for a circle. Given a circle has a center HK and radius R, the standard form is this. Now, there's a really special moment here. It's an aha moment, and we're going to want to savor it, okay? All right? But first we got to answer the second question. Then we'll get to the real aha moment. There's going to be 2 of them. And you're going to say, oh, wow, this is amazing. If the circle has a center 0, 0, then the equation is, so HK right now is the center, okay? But if I put in a 0 in for H and a 0 in for K, what does the equation become? X squared plus Y squared plus R squared. What is that? The Pythagorean theorem, Casey Gilbertson says. She's correct. Second of all, do you see what this is? What if I wanted to... What? What? Come on, Skywalker, say it. Midpoint, come on, that's dumb. What's it? Distance formula, that a boy. Midpoint has 2 coordinates. If we want to solve for R, we would square root both sides, right? Look at that. Right? Is that what you do? See how it's all connected? Now, Sarah, I don't know if you've just gotten tired or if that was too much, you like blew a head gasket. Oh, or did you think it was just that wonderful you're trying to savor the moment? Okay. All right. Well, let's put it all to use. You guys are going to say this stuff's easy. Watch. We want to write an equation for a circle that has a center at -3, +2. So this is my H value, and this is my K value. So what will the first part look like? X plus 3, very good, Danny, quantity squared, plus y minus 2, quantity squared, equals 16. The radius squared. You got to square everything. Just like the Pythagorean theorem. All right? Okay, center 0, -5, radius 1/2. And some people says that 1/2 cups. No, I had the C. I didn't get the tab in there. I'm sorry. This is problem C. So. Okay, so center 0, -5. What's the first part going to look like? X squared plus y plus 5 squared equals 1/4. Very good. So you guys could do this, can't you? How about the last one? Center at 3, 0. X minus 3 squared. Then what? Plus y squared equals 3 squared is 2. No. What do we got to do with 3 squared is 2? Square it. What do you get when you square 3 squared is 2? 9 times 2, which is 18. Very good. Piece of cake upside down. Last year's calculus class would say, don't say that. It always makes me hungry. All right. Identify the center and the radius. What's the center of this one? 3, -2. What's the radius? 4. So let's suppose that you wanted to graph this. Let's suppose you wanted to graph that circle. What would be the first thing that you would do? Danny says plot the center. He's on a roll. 1, 2, 3, down 2. That's my center. Now what? Up 4, over 4, down 4. So go up 4, right 4, down 4, to the left 4. Oh, same thing happened second hour. Somebody thought, they said, well, that's not a very good circle. They thought they could do better. Do you guys think Casey could draw a better circle than me? You want to try drawing a circle, Casey? What? I bet you have no chance. You got 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. You said draw. You inserted. It doesn't count. This isn't even a drawing menu. It's an insert menu. So take that, Julia. All right. Okay. What's the center of the next one? Center. 0, -3. What's the radius? Trent, you had it. 4 squared root of 3. Yeah. Square root of 48, which is equal to the square root of 16 times square root of 3, which is 4 square root of 3. See, Trent? Trent, when you sit by Jensen every day, it wears on you, doesn't it? You lose your confidence. She calls you stupid, and then you... Oh, Jensen. Jensen, if you're watching this, we need to have a conversation when you get back. That's all there is to it. We care about everybody's learning, and tomorrow is anti-bullying day. Yes, wear orange tomorrow, everybody. One more problem. Problem A. That tomorrow you have a video on B and 8, and that will be it. Okay? Video. Yeah, so Shabluski will be here, and he'll quick play the video for you. So you'll have just those 2 problems for notes, and you'll have the whole rest of the time to work on your assignment. Okay? So, last problem. show that the following equations represent circles by placing them in the standard form. So if they're going to be in standard form, that's my key phrase. It needs to be x minus h quantity squared plus y minus k quantity squared equals r squared. So you tell me, what do I have to do to make it in that form? CTS. Complete the square how many times? Twice. Once for this, once for that. So what I'm going to do is I'm going to gather all my x's right here, and I'll leave space there for completing the square. Plus y squared minus 12y. I'll leave space there for completing the square, and then equals 7. So I need to complete the square for the x's. What should I add? Skywalker's got it, 16. We add 16 to both sides. $36. Billy Barber has it. Tyler Eggy tells her the answer. All right, so this factors down. X squared minus 8x plus 16 factors down to x minus 4. Quantity squared. Plus, parentheses, what? Y minus 6 quantity squared equals 59. Now, do you see why we did that? Why would I put it in that form when it was in that form? What's the point? Because now I know what? Now I know the center. The center is positive 4, 6. And the radius is square root 59. That's it. Now, the other two problems are slightly more difficult, but we'll do those tomorrow. There'll be a video. Shabuski will turn it on. No talking baseball, only doing that. Just a short number of problems. Page 102, section 1-8, 45 through 55 odd, 73 through 75, 81 through 83. I will not add to that tomorrow. So that's it. Our goal is to take a test Wednesday next week, 1 week from tomorrow, right before you go back on for break for MEA. Test on Wednesday. Oh, you got mini tests that day? So should we do it Tuesday then? Probably forget everything. All right, good luck, everybody.